Hello everyone, sorry for the delay. Had some tech issues to sort out, but we are here now. So I guess one of my next things for streaming and stuff is to get some slides together that I can put up um in case the anything happens, so I can put something up and still have the stream running. But hopefully, anybody that came by will see a post, and if they come back, they'll be back. Otherwise, today we are going to, do some combining like terms. This is something that's really useful in math, and it also technically can kind of apply and I'll talk about this a little bit too. It can apply to fractions as well. So if we have any issues with fractions, maybe this will help out too. So first, let's get our title up here. So I like to have that up here. So we're doing combining like terms today. I'm going to talk about some stuff with that. So with combining like terms, the main focus here is that you want to make sure whatever you're combining is the same exact type of term. So like terms is anything that is the same type of number. So usually when you start out, you don't have to worry about this rule. Except like I mentioned earlier, unless we have fractions, because your plain numbers, I like to talk about them, like plain numbers are also the official math term is constant. Your plain numbers are like terms because they're all plain numbers, they're all constant. So they match up already, so you're allowed to add, subtract, and work with them regardless. Then so let's write this down. So types of terms. So we have constants. I call them plain numbers. So I think calling them plain numbers just kind of makes it make more sense to students because they're plain normal numbers. So what you're used to. Um, so that's things like 6, -2, 0, 1, 28, -84, those types of things. So those are our plain numbers, our constants. You can work with them normally. But then we have our variables. And the variables are what you guys see when they make that joke. Math was hard enough, why we have to add letters to it. So the variables, remember, variables really work with them in math. We kind of just talk about them at first, but then when you get into them a little bit more, we learn that the variables are supposed to be placeholders so that if you are given, you learn about them in the basic form originally, but then, later on when you start doing more problems with them, you learn that they can be placeholders so that you can figure out a situation, because if we don't write down math, sometimes it makes it hard to work with. And you can put in a placeholder, like variable, so that you can write down your question, because if you don't know what number is supposed to go there, you need something there. When you're younger and you're learning stuff in elementary school, you used to sometimes use a question mark, or even when you were in kindergarten and you did math operations as well, they would say, what number plus 5 is 8? That's technically an algebra problem, so you guys have technically been doing algebra since elementary school. So the boxes that you would draw, the shapes you would draw to hold that place, that also technically is a variable because it was a placeholder for your number that you were looking for. But typically, we use the letters once we get farther on. Okay. So we've got X, A, Z, T. I don't like using T as much. Unless you throw the T like I just drew it, where it's kind of like a backwards J. Because if you play on how you write your T's, you can get that mixed up with the plus sign. That's also why, this is what, with the live streams, I kind of just want to if I have a thought, it makes me a little bit. That's also why, in higher level math, they stray away from using the X as the multiplication symbol, and they either use the asterisk, or the circle, or you'll just see, like, the two numbers in parentheses, which will also represent multiplication, because then you'll have to worry about getting the X mixed up with the multiplication symbol. So, with that, so let's get rid of that. So, like terms, need to have the same exponent. They also need to be the same letter. So like terms need the same exponent and letter. So for us, 6 plus x. These are not like terms. One is a plain number and one is an x. They are not the same type of term. Actually, we'll leave that 6 there. 6x plus x, though, would be like terms because they both have the x included and they both include the x. And if you watch my very first video that I had into this, I talked about my reference of why x is not 1, which is a common misconception. This 6x means there's 6 of the x's, and if we add an additional x to it, that would make a total of 7 of the x's. So I just did 6 plus 1, which gave me 7. Then we'll leave that there. So next thing to talk about with this, the next one here would be, we'll use 5x minus 3x squared. So 5x has an x, that 3x squared has an x squared. The exponents are also different. They create a different type of term. So I cannot combine 5x and 3x squared because they need to have the same letter and exponent. However, if I had 5x squared minus 3x squared, that would be the same type of exponent, so it would work. We could combine them. 5 minus 3 is 2, so that would give me 2x squared. So here we have the same letters and the same exponents, and that allows us to combine these terms. So I'm just kind of going through this, because this is going to be longer explanation. So leave the explanation up there. Pardon me.
Mic off. Mic on.
There we go. Okay. So, next one. And this is another thing that messes people up. I'm gonna be writing three terms in here. Um, so if I had, and we'll switch from using X, 3A, and then I wrote an X anyways. 3A plus 2AB minus 4B. So here, once again, we need to have the same letters and the same exponents. So in this, 3A only has an A. 2AB has an A and a B. And B only has a B. So none of these are like terms because none of them have all of the same letters. So in order to have the same letters, they either need to all only have an A, only have a B, or have both the A and the B. Having the same two letters also counts. So I'm gonna do something that also typically trips people up, and I'm gonna turn this 4 into the like terms. You'll notice I started off by showing examples that weren't like terms and I turned them into like terms. So if I added a to that 4, now here's the thing that messes people up. Some people don't recognize 2AB has an A and a B. 4BA has a B and an A. But even though they're in a different order, they both have an A and they both have a B. Since they both have the same two letters, even if they're out of order, they are like terms. Something else you can do with this to help you if you're doing things like this is go through all of your terms at the beginning, and if any of them have multiple letters involved, you are allowed to do this because you'll learn. Maybe I'll do a video on these later. Um, if you're in this stage of algebra, you would have learned about the algebraic properties. One of them is the commutative property, and that applies to multiplication. And technically, with the 2AB, it stands for 2 times A times B, which means we can move them around because in commutative property, we can rearrange our letters and numbers. Same thing with the 4BA. It stands for 4 times B times A, which means I'm allowed to move them around. So if I wanted to switch the order of the A and the B so that these both say AB, I can do that. So now I have 3A. 3A is the only one that only has an A. But then I have 2AB minus 4AB. So I'm allowed to combine those two because they are like terms. So when I combine these, the 3A doesn't have anything to combine with, so it would stay the same. And then here's another trick I like to do. So when I'm combining like terms, I don't write my symbol. So right after the 3A is a plus, I don't write my symbol until I know whether the following number is positive or negative. Because if it's negative, you can do subtraction instead of writing plus or negative. So 2AB minus 4AB, 2 minus 4 is negative 2. That would be AB. So that will be the answer for that one. So with combining like terms, the key thing here is you want to make sure in each term the numbers and letters and exponents match up. So let's take a look at some other examples. So let's write down some random things here. Let's have this, so let's do 3x plus 4y minus 10x y plus 5. And 2, 4, 1, 2. Do one more. Okay. So let's look at this first one. So the best thing with this as well, and you learn this when you're doing different types of questions, is you want to indicate your like terms. So I usually do this with like an underline and a box. And then if I have more than 2 types of terms, I'll pick something else. So what I'll do here is in this first one, I'll go and say, okay, 3x. I'm going to look for another term that just has a regular x. 4y, it's a y that's not an x. 10xy that has an x and a y, it's not the same as just an x. And then 5x. And when you do this, you want to include whatever symbol is before your number as well. Right, so there's the x's, so then I'm going to look at the 4y. So 4y just has a y, and then that's the only one. And then 10xy has an x and a y that's different from the other one, so I'm going to do this. So now that I've had them isolated or kind of highlighted in different ways, I know which ones I can combine. So the 3x and the 5x I can combine. And since I mentioned earlier, highlight the term beforehand, before you remember that's what you use. So it's 3x. And then it says plus 5x, so that's going to be 3x plus 5x. 3 plus 5 is 8. So that gives me 8x. And then after that, and something you might want to do while you're doing this, when you take care of some terms, you can cross them off. So I took care of those x's, I'm going to cross them off. Then we have plus 4y. So that 4y is the only one, so it's not going to change, so we can just copy it over. We're done with it. And then minus 10xy. So the 10xy is also the only one, so we just copy it over. And now that we have all of those, that would be our answer. Alright, the next one I have here, I took into effect the last thing I talked about. So we have a 4y. I'm going to look for something else that just has a y. It turns out that it's the only one because the other two have a y and a z and a z and a y. Then I have minus 2yz. And I'm going to highlight this one because the other one says plus 8zy. Even though they're in a different order, they still both have a z and a y. So even though they're in a different order, they still have the same number. So since they still have the same number, the same letter, they have the same letters. Since they still have the same letters, you can combine them. And you want to take a look here, it's -2 because we have -2 plus 8. So now that we have them isolated or highlighted, we can take care of combining. So 4y is the only one. So we have our 4y. And then typically when I write our terms, I like to write them in alphabetical order. So the next one, -2 plus 8 is positive 6. So this is also what I mentioned earlier. I don't like to put down the symbol until I know if it's positive or negative. Because if we have positive number, we can write plus. If we have negative, we can write minus. So 4y plus 6, alphabetical order, y, z. Alright. Next one here. We have 7a squared minus 2a plus 3a squared minus 4a. So you'll notice all these have an a, but they don't all have the same exponent. So because they don't all have the same exponent, we can't count them. So we can't combine them. So we're going to look at them. So let's start with this a squared. Remember, they have to have the same exponent, so we're going to go through this and look for the ones that have the same exponent. So we have 7a squared minus 2a, they're different, plus 3a squared, so those are the 2a squareds, minus 4a. So then we're going to look for just the plain a's. So we have minus or negative 2a minus 4a. Those are two plain a's, no exponents. So now we have our terms highlighted. The things that are underlined go together. The things that are in boxes go together. 7a squared plus 3a squared. 7 plus 3 is 10. A squared. Negative 2a, because it's a minus sign, negative 2a minus 4a. And this is another thing that I have where I use different phrasing because I find it helps things make more sense. If we do a negative and we subtract from it, it's going to get more negative. More negative is a phrase that I like to use because it helps people. It seems to, so far, have helped students understand how when we subtract, you're going to go farther down the negative, which becomes a bigger number, but a negative number. So, negative 2 minus 4 would give us negative 6. It got more negative a. Negative 6a. Alright. So there's 3 examples. So the next thing I want to do, I mentioned this earlier, I want to also take some time to kind of like meet my time frame. Have a little while still. I want to talk about how these like terms also relate to fractions. So when you have fractions, a lot of students shy away from fractions because they feel like they're really complicated. But if you're decent enough with algebra, or at least if combining like terms with algebra makes sense to you, then this will hopefully help as well. So how do we open this? Let's start with this. So how fractions relates to combining like terms. We'll have to just put that one word on the next one. So how fractions relate to combining like terms. So when you have fractions, you've been taught in the past that in order to add two fractions together, so let's use 3 over 4 plus 1 over 8. In order to combine fractions, they need to have the same thing at the bottom. So I'm going to kind of take something here, and it's gonna look a little weird. So, 3/4, 3 over 4, 3/4, you say it as 3/4, means that there are 3 1/4, 3/4, plus 1, I'm gonna use the 1/8. These are different types of fractions. So because they're not the same type of fraction, we can't add them together because the 1/4 and the 1/8 don't mesh together. This is why we have to change the fractions, because I can't just do 3 plus 1 and then say I have 4/8 because the other ones are an 8. Or I can't do 3 plus 1 and say I have 4/4 because they're not both types of fourth. So this is why we convert our fractions. That's got crazy. So what we do is we adjust them. You can't really do this with the variables. Because it just doesn't work out. But since we know what numbers they are with the fractions, we can alter them, and we do this by changing the type of fraction so that they do match, because we can make them match. So if I wanted to turn, usually I take a smaller number and change the smaller number. If I wanted to turn the 4th into an 8th, I'm gonna do it with the top part because that's how we do it. We would ask ourselves, what can I multiply to turn 4 into an 8? Well, 4 times 2 is 8. But we can't just change the bottom because it makes a whole different fraction. So whatever we change to the bottom, we have to also change to the top. So if I'm going to multiply the bottom by 2, I gotta multiply the top by 2 to keep it balanced. Because if we do in fractions, if we change one part of it but not the other, it just alters the number. But if we change both parts the same way, it keeps it balanced, which technically keeps it as the same number. And since this is a specific fraction lesson, I'm not going to go into more depth about that. I have been creating fraction videos, so you can check those out as well. So, let's take a look here. So, 2 times 3 is 6. 2 times 4 is 8. Plus 1/8 didn't change. Now there's 6/8, which means we have 6 1/8, 6/8 plus 1 1/8. Now, these are the same type of fraction. So now that they're the same type of fraction, they are like terms, and we can combine them. And I'm gonna do it down here first. So it's 6 plus 1 is 7. 1/8. Same thing here, 6 plus 1 is 7. So 7 times 1/8, that works back into also being 7/8. So when we do that, This is just kind of like a visual way of combining fractions. You might look at it and be like, oh, well, that looks so weird. But like I said, it's kind of like a relation to how combining fractions, adding fractions is similar to combining like terms. So if you are in algebra, or if you watched the first part of this and combining like terms made sense to you, then hopefully maybe this fraction part made sense to you too. And it works with subtraction as well. So there was a subtraction question, this would also work. So I'm just gonna do another one to just kind of show this a little bit more. Do this in blue because I didn't use blue on this part of the screen yet. So I'm gonna do a harder one. So, we'll do 3/5, and I'll do subtraction since I brought up that it works for subtraction as well. 3/5 minus... I don't want to... Yeah, we'll just do it. 5/6. So, 3/5 minus 5/6. So remember, if the combining like terms thing made sense to you, 3/5 means there's 3 1/5 minus 5. It's almost the same thing again. 1/6. 1/5 and 1/6 are not the same type of fraction, so we cannot combine them. We need to have the same type of fraction in order to combine them. So, we need to find a number that we can multiply 5 by that will be a number that 6 can become. So, without this being, like I said, a super in-depth fraction lesson, because I'm going to have specific videos on that. If you don't we use least common multiple for these. But a surefire way to make sure this happens, if you're not good at least common multiples, is to just trade bases. So what I mean by that is just swap. So the 5 will multiply with the 6. So multiply the second term by 5. The 6 will multiply with the 5. So multiply the first term with the 6. So if you just swap numbers, trade the numbers, it'll always work. It just sometimes that makes it bigger, and if you're worried about having super big numbers, you would want to look for the least common multiple. So for example, in that first one, I could have just multiplied the first one by 8 and the second one by 4, but that would have made really big numbers, which then might cause us to need to simplify fractions some too. But this one, the 5 and the 6 don't actually have the least common multiple before the 30. So we would just trade those numbers like that. So, this becomes 6 times 3 is 18, 6 times 5 is 30, minus 5 times 5 is 25, 6 times 5 is 30. So now we have 18 1/30 minus 25 1/30. So now they're both forms of a 30th. They're the same type of fraction, so that means we can combine them. 18 minus 25 should be -7 over 30. Same thing here. We're using the 30ths kind of like a variable. So 18 minus 25 still -7, 1/30. And then you can multiply that -7 back into the top, which still gives us -7 over 30. Now that bottom part is more just for the visualization of understanding how it works, but in reality, you're really probably, once you understand it, that top parts is what you're gonna use to do all of your work anyways. But if the visually that helps, then that would be a good thing to use. So, I will say I don't think I've ever seen fraction combined like, the fraction combined like term sync before. That's something that I just kind of thought of recently, but I thought maybe would make sense. Um, so if you're a teacher that's watching this, feel free to steal that if you think it'll help any of your students. If you're a student that's watching it, feel free to use this to help you understand anything. And then that's all I have for this week. I know it's a little bit, I mean, they're always kind of short, but I know that this one's a little shorter than normal. But hopefully I was able to make your math lives